Okay, let's give you guys some more practice. So here, find the quadratic approximation for f of x equals e to the power of x near x equals 1. So x equals 1 is here, so that will be right here. So it's like me asking you to find out the quadratic approximation. So your quadratic might look something like this. Okay, the important point is this here, or it could even be upside down. It could be something like this. But well, anyway, find the quadratic approximation, and whenever you get given, find the approximation of something near x equals 0. You see, when it's something like this, this is much easier to do than when it's away from x equals 0. Well, anyway, find the quadratic approximation here. You see, whenever you try and find the quadratic approximation at x equals 0, it's much easier to do than when it's at 1. Okay, well, anyway, you see what I mean. Press pause and have a go. Okay, so to do this here, start out with your quadratic. So your quadratic will be in this form here. Okay, and the idea here is well, at x equals 1, here, which is this point here. The idea here is to get your quadratic, get the derivative. The idea here is to get your first derivative of your quadratic to be the same as the first derivative of your original function, red line here. And then the next step is to get the second derivative of your quadratic to be the same as the second derivative of the red line here at this point here. Okay, so it's just a trick. Okay, it's just a trick to find your approximation. So start out with your quadratic here. So so hang on. But before we look at the derivative, let's just look at that point. So put 1 into here. Put 1 into here. So what our aim here is to create a quadratic like this. Our aim here is to find out a, b, and c. Once we've got a, b, and c, then we've got our equation for our quadratic. But the way we do that is first let's put 1 into here. So when we put 1 into here, it will give us this here. Now the normal value of the function. So when you put 1 into here, it will just be the number e, or if you like, e to the power of 1. But it will be e when you put 1 into here. So we've got to use this equals this later on. Okay. Remember, our aim here is to find out a, b, and c. But this is what we've got so far. Now let's look at the first derivative. So looking at the first derivative. So just remember, later on we're going to use this equals this. Okay. So starting with this here, differentiate it, because now we are looking at the first derivative. So when you differentiate it, we'll give this. Now look at the first derivative of our original function. That will then give us this. Okay. Now, because we are evaluating it at x equals 1, put 1 into here. So that will then give us hang on, I've made a mistake here. Sorry. That will then give us. Oh no, it's okay. Sorry. Hang on. Start again here. We started out with this here. Differentiate it. It will give you this. Okay. When you differentiate it, it will give you this. Now put 1 into here. Okay. So put 1 into here. Then when you put 1 into here, this here will be 1 because it goes into there. So this thing here will be 2a. And then the b is still there. Okay. So this the first derivative of our quadratic at x equals 1 will be this, definitely, for sure. Okay. And then now look at the first derivative of our original function. So when you put 1 into here, it will still be this. Okay. So now earlier we had this. We have to set this equal to this. Now we have to set this equal to this. Okay, so later on we're going to use these two, then we're going to use these two. Now let's look at the second derivative now. So looking at the second derivative, starting from here, differentiate it, that will give us the second derivative. Okay, now looking at the original function, here this is the derivative of the original function. Differentiate it, it will give us the second derivative. So now put 1 into here because we are evaluating at x equals 1. So put 1 into here, and then our second derivative at x equals 1 will be given by 2a. Okay, and then when you put 1 into here, it will just be e. So really we've got this thing. We have to set this thing equals this thing here. Set these to be the same, and then set these to be the same, and then set these to be the same. Okay, set this. So here these two are the same. So now it's just solving simultaneous equations now. So we've got this equation here, we've got this equation here, we've got this equation here. So somehow find out a, b, and c from these three equations here. Okay, so let's first look at this one here. So a is quite easy to find. A is simply divide both sides by 2. So a equals this here. And now look, now we're going to put this a into here now. So that will then give us this. Okay, that will then give us this, because from here we found a. So once we've got a, we can then use the second equation here, put it into here. So this 2 here is here, and this a here is this a here, and the b here, e here, and the e here. So somehow blah 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 solve it. B equals 0, and then blah blah blah, and then blah blah blah. C equals this thing here. Tidy it up. It will then give you this. Tidy it up, and then C equals this. So we've got A, B, and C. So now don't forget A. Yeah. So A happens to be E over 2, and then I skimmed through it. But B is actually 0, and then C is this here. C is E over 2. So now so now remember Q of x equals ax squared plus bx plus c. So now we've got our a here, so put it into here. B, put it into here, and where's our c? C plus c here. So c, put this into here. Okay, so that will then give us this. So now if you get a graph plotter, plot your original f of x equals e to the power of x. That will give you this this red line here. Okay. Now plot our quadratic approximation, which was this here. That will then give you the blue line here. You see, at x equals 1, it is a pretty. So here this is 1 here. So at x equals 1 right here, our blue line is a good approximation to the red line here. Okay, pretty good.